Hello everyone again. In this recording I will talk about the curvilinear motion. The curvilinear motion it's generally two types. One is in the circular motion, the other one is in the any general case. It's on the any curve. But for the curvilinear motion, the main important part is that the particle, I mean, is constrained to move in a circle, in a curve. So if it is constrained to move in a curve, so it means that there is something that acts on it. So in this case, so there is an acceleration towards the center of the body. You can see it cannot fly away, but it is constrained to move in this circle. So it means that there is something that acts on it. I mean, it's not like kinetic, like force. It's more about the kinematics, like the acceleration. This acceleration keeps the body in circular motion. And this acceleration is acting inwards, you can see, and towards the center. And this acceleration keeps the body in a circular motion. Okay. And then we have some concepts here. The path, which is the path it travels. The velocity is the, let me erase this one. This is the velocity. So tangent to path. Then we have the tangential acceleration. This is very similar to acceleration we know. The acceleration that we know. This is like the acceleration that you have when you drive your car. You increase the speed, decrease the speed. This is what the tangential acceleration is. Because since the velocity is tangential to the path, the tangential acceleration increases or decreases the amount of the velocity. So it is increase or decrease. This one is very important, the magnitude of the direction of, let's say, tangentially. Okay, it increases or decreases. As you can see, if it increases, then the body will move very fast. If it decreases, then body will move slowly around this curve. Okay, and the normal acceleration is, what it means is that it keeps body in a curve. So let me show you this one in the second one, which it will be clear. So if the particle is here, it will have this normal acceleration an, and this tangential acceleration at. Okay, and then if the body is here, there is only at. Here, no an. There is no normal acceleration. It's like a straight path. It is straight path. There is not something that keeps it in the curvature. So there is no normal acceleration. This normal acceleration is also called, you can say it like the centripetal acceleration. These are different terms, but let me just not confuse the things up. Okay, the normal acceleration is what it acts and keeps the body in a curvature, you can say in simple terms, but it changes direction as well. For example, if the particle is here, the normal direct acceleration is this way, the tangential acceleration is this way. Okay, and this normal an directed to center of curvature. Okay, And this normal acceleration is, so if it is the, so you just look at a section of it. Yes, for this section, this is the center, O. And then for this section, this is the center. Let's say O1 and then O2. And but for this section, there is no center because it's straight line, and then straight line, the radius tends to infinity. There is no radius, it's infinity. So if we summarize things up before solving the problem, the normal acceleration is what it keeps the body in a curved path, and then tangential acceleration is just like the acceleration that we know on the road, and then the body that's what we know. And if there is no normal acceleration, the thing will become like a straight line, rectilinear motion. And the formulas, there is a formula for an, that is v squared by rho. What is rho? Rho is like this is radius of curvature. So what it means is that, let me talk about firstly circle. If it is circle, and this is your rho, which is equal to radius. If it is something like this one, and then you have to look for rho per each section. So for this section, this is the center and that is rho. For this section, this is the center and that's rho 1 and rho 2, O2 and then O1. And this is what it means, that v squared by rho. Okay, with this one I will stop the introductory part and move to the problem, and then we will talk about more on the concepts while solving the problem.